Hi, Assalamualaikum and a very good morning. So today we're going to do some tutorial discussion for chapter 11 and we're going to focus on the subtopic of 11.1 Introduction, 11.2 Nomenclature, 11.3 Physical Properties of Amine. And now we're going to do tutorial question 1, tutorial question 2, tutorial question 3 and tutorial question 4 respectively. So without any further ado, let us start. So for tutorial question 1, we have to classify the following amines as primary, secondary or tertiary and give their IUPAC names. So for the structure 1b, we were given this structure here. So in order to classify the compound, we have to look at the nitrogen atom here. Okay, so the nitrogen here is attached with 1 and 2 alkyl group. And therefore, this amine gonna be a secondary amine. Okay. Now we're going to give their IUPAC name. So in order to do the IUPAC name, we have to find the longest carbon chain that is attached to the nitrogen here. So the longest carbon chain here going to be 1, 2, and 3 or vice versa. Okay, so 1, 2, 3 going to be the longest carbon chain and it is attached with the amine group here. So it's going to be propane because 3 alkyl group, but because it's attached with amine, so it's going to be propanamine. Okay, and then the amine group is attached at carbon number 2, so it's going to be 2-propanamine. Okay, and then the nitrogen here going to have one substituent. So this substituent here, if you were to expand, you're going to get CH, and then you're going to have CH3 and CH3 here. The others, you just copy back again. Okay, so this substituent here, as what you can see, has 3 alkyl group and it is look like Y. And because it is symmetry to one another, it is known as isopropyl. Okay, so the substituent that you have is isopropyl. And the isopropyl is attached at N. So you're going to say it's going to be N-isopropyl 2-propanamine. Okay, so the full name going to be N-isopropyl 2-propanamine. Alright, now moving on to the next structure here, which is structure C. We have C6H5CH, CH3, CH2, and H2. So if you find it difficult in order to imagine the structure, I will suggest you to draw. Okay, so as what you can see here, it has C6H5, so you know that it is a benzene ring, and then it is attached with carbon, hydrogen, and then it has a substituent of CH3 up here. Okay, this hydrogen going to be below, and then this going to attach with another CH2 and then NH2. Okay, so the structure going to look something like this, or if I were to draw it nicely, I will get something like this. Okay, and now the same thing, you have to find the longest carbon chain that is attached to the amine group. So I will get 1, 2, and 3 here. Okay, so 1, 2, 3 here refers to propanamine. Propanamine, and then this amine here is attached at carbon number 1, so it's going to be 1-propanamine, and then I will have my substituent at carbon number 2, which is phenyl. So I'm going to say it's going to be 2-phenyl 1-propanamine. Okay, and it is a primary amine because the nitrogen here is only attached with one big alkyl group here. Okay, and the name going to be 2-phenyl 1-propanamine. Okay, now for the structure E here, we were given C6H5 and CH2CH3, and then we're going to have CH2CH2CH3 here. Okay, and if you were to expand this structure, what you're going to get is a benzene ring attached with N, and then it's going to have CH2CH3, CH2CH3, and it's going to having CH2CH2CH3. So you're going to have 1, 2, and 3 here. Okay, so as what you can see here, it has a almost a similar structure of aniline. Okay, but one hydrogen is changed into ethyl and another hydrogen is changed into propyl. Okay, so the parent name, because it follows aniline, so the parent name here gonna be aniline. Okay, and you're gonna have two substituent, so we have ethyl and propyl here. So we're gonna write propyl first because we have to follow alphabetical order, and the propyl gonna attach at N. At the same time, the ethyl is also attached at N, so it's gonna be ethyl N here. So the full name gonna be ethyl and propyl aniline. Okay, and if I were to write it nicely, okay, and it is a tertiary amine as what you can see here, and if I were to write it nicely, I will get N-ethyl and propyl aniline. Okay, so that's for question number 1. So for question number 2, we have to draw the structural formula for each of the following compound. So for 2A, we have 3-aminobenzoic acid. So benzoic acid basically is a benzene ring, but it's attached with COOH. So it is a benzoic acid. So this one going to be carbon number 1. But now because it have amino at carbon number 3, so we're going to place NH2 here. So it's going to be 3-aminobenzoic acid. Okay. And now for structure E here, we have N-butyl and ethyl aniline. So it is similar to the structure of aniline, which is NH2, but one hydrogen is changed into ethyl. Okay, so ethyl 1 and 2, and another is changed into butyl. So you're going to have 1, 2, 3, and 4. So your structure going to be looking something like this. Okay, and now for the structure D here, we have N-dimethyl 1-butanamine. Okay, so butanamine, 1-butanamine gonna have 4 carbon, which is CH3, CH2, 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 and H2. Okay, so this one is butanamine. Okay, but the hydrogen here is going to change. 2 of the hydrogen here is going to change into 2 methyl group. So it's going to be attached with methyl group and it's going to be changed into methyl group. So it's going to be NN dimethyl 1-butanamine. Okay, so your structure going to look something like this. Okay, so if I were to draw it nicely, I will get something like this. Or you can also write it as CH3, CH2, 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 and CH3 bracket 2, which refers to the end here. Okay, so that's for question number 2. Now for question number 3, we have to explain why the boiling point of N-dimethyl methanamine is 4 degrees Celsius while 1-propanamine is 49 degrees Celsius. Okay, so let's extract the information out. So N-dimethyl anamine 4 degrees Celsius and 1-propanamine is 49 degrees Celsius. So the structure of N-dimethyl anamine is basically CH3 and H2. This one refers to methanamine, but the 2 hydrogen here are going to be changed into methyl and methyl. Okay, so it's going to be N-dimethyl methanamine. Okay, so it's going to look something like this, where the N here is attached with 3 methyl group. Okay, and this structure here is also known as the trimethyl amine. Trimethyl amine. Okay. Okay, and the trimethyl amine here, as what you can see, it is a tertiary amine because it is attached with 3 alkyl group. Meanwhile, for 1-propanamine, it will have 3 carbon, and at the end, it's going to attach with the amine group. Okay, so it's going to be 1, 2, 3, and then amine. So here it's going to be a primary amine. Okay, and as what you know, the primary amine will have the higher boiling point because it can form hydrogen bonding between 1-propanamine molecule. However, the tertiary amine will not be able to form hydrogen bonding within themselves. Okay, so what you can say here is that one propanamine can form hydrogen bonding, meanwhile the N-dimethyl enamine can only form weak van der Waals forces. Okay, and hydrogen bonding is a strong intermolecular forces. Thus, more energy is needed to break the bond between one propanamine molecule because it is an intermolecular forces between molecules. And hence, you can say that the boiling point of one propanamine is higher than N-dimethyl enamine, which is 4 degrees Celsius. So, we have explained why the boiling point of one propanamine is higher. Okay. Now we're gonna look into the question 3C here. So for question 3C, we have to arrange the following compound in ascending order of basicity. So we have to explain the answer. So we have ammonia, we have methylenamine, we have aniline, and also p-nitroaniline. Okay, so these two here is an aliphatic amine. This one here is aromatic amine. Okay, so aliphatic means it is a zigzag chain or have a straight chain. Aromatic when it have a benzene ring. Okay, so the aliphatic amine will have higher basicity than aromatic. Okay, because in aromatic the electron are being delocalized inside the benzene ring. However, aliphatic will have more electron density on the nitrogen. So for here, I can say that the methylenamine will have the highest basicity because it's going to have CH3 and H2 here. Ammonia going to have NH3. Okay, so the CH3 here will provide more electron density towards the nitrogen. So the nitrogen will have more electron density and hence it can pick up more electron more easily. Okay, so methylenamine going to be the most basic, followed by ammonia. And the third going to be aniline because aniline going to be less basic than these two because the electron going to be delocalized inside the benzene ring. Okay, and the p-nitroaniline. So p-nitroaniline basically the structure of aniline, and it refers to para, which is 1, 4. So you're gonna have 1, 2, 3, 4. At carbon number 4 is gonna attach with the nitro group. Okay, so the nitro group here is the electron withdrawing group. So it will pull electron density towards itself and hence make it less electron density and hence less basic. Okay, so now you have the 1, 2, 3, 4 here. So you can say that the basicity of p-nitroaniline gonna be lesser than aniline, lesser than ammonia, and the highest gonna be methylenamine. Okay, so let me erase first. Okay, and the next explanation what we're gonna do is alkyl amine, which is the CH3NH2, are slightly stronger base than ammonia. So an alkyl group is an electron donating group. This makes the CH3NH2 more basic because it will donate electron density towards the nitrogen here. And then we can say that aniline is weaker than ammonia because the lone pair electron of nitrogen of aniline is being delocalized into the pi system in the aromatic ring. And lastly, the nitro group of p-nitroaniline here is an electron withdrawing group, okay? And which withdraw the lone pair of electrons from the nitrogen of aniline more strongly, and this make the basicity of para-nitroaniline lower than aniline. Thus, the p-nitroaniline is the least basic. Alright, okay, so this is the explanation for 3C. Now for tutorial question 4, we have to arrange the following compound in increasing order of boiling point. Explain your answer. So as what we can see here, the 1-propanol here is an alcohol. Ethanoic acid is a carboxylic acid. Chloroethane is haloalkene. And 1-propanamine is an amine. Okay, so the haloalkene here cannot form hydrogen bonding. Meanwhile, amine, alcohol, and carboxylic acid can form hydrogen bonding. Okay. So haloalkane gonna be, because it cannot form hydrogen bonding, so it gonna be the lowest boiling point. So it's gonna be take number 4. Okay, now alcohol, carboxylic acid, and 1-propanamine can all form hydrogen bonding. However, amine will have the weakest hydrogen bond because the nitrogen is least electronegative in comparison to oxygen. Okay, so oxygen is more electronegative than nitrogen. So because it is less electronegative, then it's going to be lower boiling point in comparison to alcohol than carboxylic acid. Okay, and when we compare alcohol and carboxylic acid, we know that carboxylic acid can form dimer. So it gonna form hydrogen bonded dimer, which is very stable, and hence it's gonna be the highest boiling point. And the second gonna be alcohol, the propanol, which is an alcohol. Okay, so that is the idea. Okay, so you can say that the chloroethane will have the lowest, followed by propanamine, and then 1-propanol, and then ethanoic acid. Okay, which is the carboxylic acid. So I will erase this one first. Okay, so this is the answer here. And then for the explanation, you can see that the boiling point of chloroethane is the lowest amongst all because chloroethane has no existence of hydrogen bond between the molecule, but only weak van der Waals forces. And the boiling point of 1-propanol is higher than 1-propanamine because the hydrogen bonding in 1-propanol is stronger than 1-propanamine due to the higher electronegativity of oxygen than nitrogen in amine. Okay? And the ethanoic acid has the highest boiling point compared to 1-propanol because it can form stable hydrogen bonded dimer. So acid gonna be the strongest, and the structure gonna be something like this. So this is ethanoic acid, and it can form stable hydrogen bonded dimer with the other molecule of ethanoic acid. Okay, so the term here need to be correct: hydrogen bonded dimer. Okay, and this is why the ethanoic acid is the strongest, will have the strongest hydrogen bond, and hence will have the highest boiling point. Okay, so I think that's all for today's video. See you again some other time. Bye.